Hey folks, I've had a question about number 18 here. Now this is from the Gamma textbook for year 11, and this is, I think, this is exercise 12.01. This is the last question, it's question 18, and I'll just go through this one. I really like this question. It is so cool. Okay, so we've got a parallelogram, we've got a trapezium, in fact, we've got a trapezium with, it says ABCD is a rectangle, ABC is a parallelogram, the measurements are in centimeters. So we've got some kind of a parallelogram here, and we've got a rectangle here, and the whole thing, of course, together is actually a trapezium. Measurements are in centimeters, and we've got an 8 and I've got a 15, and we need to find certain things. The first thing it says is use the theorem of Pythagoras to calculate the length BD. Now, I always find it best to just strip away all the lines, angles, and letters and things we do not need, and just concentrate on the bit that we do need. So really, we're looking really at just one triangle here. So here is 18a, so I'll rewrite this out. This is 18a, and this is exercise 12.01 from Gamma. Okay, so here it is. So I'm going to redraw this here. I'll make it a bit bigger as well. So here it is, and we're told that this bit here is 15. Excuse the crudeness of the triangle. It's not well drawn. This is 8 here, and it says find the length of BD, which of course is this length here. That's letter B, letter D. So really, I'm going to call this side X. Yeah. Now we can use Pythagoras' theorem to calculate that, and we know that in this case, x squared is going to be 8 squared plus 15 squared. All right, so let's go ahead and do that. So x squared is going to equal, well, 8 squared is 64, and 15 squared is 225. And if you have trouble doing that on your calculator, or if it just, nice and simple, really, do it on the calculator. 225 and 64, well, 4 and 5 is 9, 6 and 2 is 8, and we've got a 2 out in front, so we've got 289. Now we've got x squared is 289. Now, you probably should actually really know what that is. And this is where knowing squares up to 20 is a really useful thing. But just to be sure, you can just do it on the calculator. So we've got 289, so the square root of 289, and it's number 17. Here we go. So we've got an x is equal to 17. Now, of course, finding a square root of both sides, which is what I've done here. Really, of course, this is a plus and a minus, but you can't have a negative distance. You can have a negative direction, but you can't have a negative distance. So this is going to be 17, and it's going to be, is it meters? No, it's centimeters. Everything's in centimeters. So we now know this thing here is 17. So I can just write in 17 here. And these, of course, we'll just remember they're all in centimeters. Now, the next bit says, explain why rectangle and parallelogram have the same area. All right, so the rectangle and the, well, this really depends upon the equation that you're using. So first of all, let's look at the rectangle. So the rectangle, and I'll redraw the rectangle. Here it is. The rectangle is, and the equation for a rectangle, the area is equal to base times height, or length times width, or however you want to do it. And this is 8 times 15. Well, of course, the parallelogram actually has exactly the same dimensions. It just looks like this. Yeah? So there it is. This length here is 15. And this side here, of course, is 8. So the area of a parallelogram is always going to be its length times its vertical height. In this case, I'm going to twist this around a little bit so you can see what I mean. Here is its length. Its length is 8, but its vertical height, that is, if I was to draw a right angle there, you can see is 15. So 8 times 15 is exactly the same as 8 times 15 here. And in case you're wondering, 8 times 15 is 120. So the area is going to be 120. The reason they're the same is because they have essentially the same equation, which is length times vertical height. You could say it's 15 times 8 because this is vertical, or you could turn this on side and say it's 8 times 15, which is its vertical height. You could do the same thing here if you want. You could say this is its vertical height, and I would actually use that, and this is its length, or you could try and do it another way, but this makes a lot of sense. So length times vertical height, and I would go ahead and use that as my explanation.